Hello everyone. In this video, we're going to see the construction, the types of rotors, and the working principle of the synchronous generator. In introduction, the synchronous generator is also named as synchronous machine, and it is used to convert the mechanical power into AC electric power through the process of electromagnetic induction. Synchronous generators are called, referred, and called in different names. It can be called as alternators, or AC generators, or synchronous generators. The term alternator came because it produces the AC power. So this synchronous generator will be driven at the synchronous speed to produce the desired AC power with the frequency. The construction, when we talk about the construction of synchronous generator or alternator, it is basically divided into two main parts. The first one is stator and the second one is rotor. Stator is a stationary part of the alternator, and it carries the armature winding, and this winding can be used to generate the AC voltage with the help of electromagnetic induction. The output of the alternator is taken from the stator. And the second one is rotor. It is the rotating part of the alternator where it acts as a field flux. So the one difference between synchronous generator and DC generator is, in DC generator, field is stationary and armature is moving. Here in a synchronous generator, field is moving and armature is stationary. So this field can use to produce the main field flux, and based on the interaction between the armature and the rotor field, an EMF will be induced in the armature. Okay. Basically, when we talk about the stator of the alternator, the stator consists of stator core, stator armature winding, and there is a provision for the cooling arrangement. This stator is made up of high graded silicon content with a steel lamination to reduce the hysteresis and eddy current loss in the stator. There will be the provision of slots, which the winding can be used in these slots. Sometimes the armature winding is in a star connected or delta connected. Based on the voltage requirement, uh, the distribution of EMF will happen. So this picture shows the stator of the alternator. And when we come to the rotor is divided into two types. One is salient pole rotor, another one is cylindrical rotor. Salient pole rotor is also named as non-cylindrical rotor. The reason is the construction of salient pole is shown where the projection poles are there. Okay, so this field pole will contain field winding, which will be ignited by the DC supply to produce a magnetic flux, so which will cut the armature. The salient pole rotor is used in a low medium speed alternators, for example 120 rpm to 400 rpm. So salient pole, the rotor is driven at high speed. If we drive it in a high speed, it would cause damage to the winding and also produce much noise. So this will be preferable for the low speed, and the rotor have large diameter and short axle length. So the next type is cylindrical rotor. The cylindrical rotor is cylindrical in shape, which can be used for the high speed application from 1500 to 3000 rpm. And this is no physical projection pole like non-salient poles. Okay, so it's called as a salient pole rotor, and this provide a greater mechanical strength and accurate dynamic balancing. And also the cylindrical rotor makes the noiseless operation, and which can be run at high speeds. So this cylindrical rotor can be used for the sine wave and have a better EMF waveform with this application. Okay. When come to the working principle of the alternator, it is almost like armature is a stationary, which consists of armature winding, and field is a rotating part, which is ignited by the DC excitation. So the field will be rotated with the help of prime mover. When it start rotates, and magnetic flux will cut the armature conductors, and the EMF will be induced in the conductor. The direction of generated EMF can be determined by the Fleming's left right hand rule, and the frequency can be determined F is equal to Pn by 120. So P is the number of poles, and N is the synchronous. N is the rotor speed or synchronous speed. Thank you.